Hi everyone, this is Mr. Mohammed coming up with another video about vectors, and today we're going to talk about the cross product of two vectors. I'm going to answer one of the questions, but of course there are a lot more ideas about the cross product and its applications in physics and in dynamics as well as statics. So I just want to let you know that this is just a simple example. Go back to your textbook and study more about cross product, but this should eventually help you understand how to mathematically calculate the cross product of any two vectors. Just to remind you in the beginning that the cross product between any two vectors will yield another vector, a third one, perpendicular to the plane containing the original two vectors. That means it's going to be perpendicular to both of them at the same time. Just think about it as I, j, k, or x, y, z, where z, for example, is perpendicular to both x and y at the same time. And if I cross product x times y, I get another vector perpendicular to both of them, which is going to be the z component. But anyway, let's jump into the question. I have two vectors, u and v, and I want to show that u cross v is orthogonal to both u and v. Of course, we need to find first what's u cross v, the cross product, and then we can think about what's the meaning of orthogonal to both of them. All right, because we need to prove that eventually. Okay, so first to arrange them into a determinant, so I should write u cross v. Of course, the arrangement matters. The one that comes in first is different if it's flipped, so it would be written like this. You have I, j, k, and I'm going to write u in green. It's going to be minus 2, 1, 3, and in yellow I'm going to write v, 1, 3, minus 2. And it's just like really simple way to remember this is the rules, the sign rules. So you have the first one is always positive, then you alternate from there. So z positive, negative, positive, and this shall be equal to I times something, j times something, k times something. Okay. So first, if you want to find the x component of that new vector that's going to be perpendicular to both of them, we need to cross its row and its column. So let's just imagine that we're crossing this one and that one, and then we just multiply these like that. So 1 times minus 2, 1 times negative 2 is negative 2, then minus 3 times 3 is 9, okay, and then you cross j, but remember that j must be negative. I made a mistake there. J should have been negative, okay, and we cross the j and its row and column. You end up with minus 2 times minus 2, that's 4, minus 3 times 1 is 3, and then lastly k, you cross its row and column, and you get minus 2 times 3 is minus 6, and 1 times 1 is going to be 1. Okay, so I'm going to make it look a little nicer. Okay, like that. So the new vector, or u cross v, is eventually minus 2 minus 9 is minus 11i. 4 minus 3, that's 1, so it will be minus j, and k will be minus 6 minus 1, that's minus 7k. So this vector, I need to use this vector to prove that it's going to be orthogonal to both u and v at the same time. So on a separate page, I'm going to take a copy of that on the other side, so it's going to be minus 11j, minus 11i, sorry, minus j minus 7k. And I need to prove that this u cross v is actually perpendicular to both u and v. So I need to prove this. Of course, when you think about orthogonal or 90-degree angle between two vectors, you always go to think about the dot product, not the cross product, because the dot product between any two vectors is 0 if they are perpendicular, or in other words, orthogonal. So I'm going to use this to my advantage. So I'm going to say, because I know that, for example, A dot B equals to 0 if A is perpendicular to B, or the angle between them is 0, that means theta is 90. So I'm going to find the dot product, and if it's equal to 0, that means it's orthogonal, right? So let's do this. So let's rewrite the original vectors U and V together right here. I'm going to go take a copy. So minus 2, 1, 3, minus 2, 1, 3, that's the first vector, and 1, 3, minus 2, 1, 3, minus 2. Let's find the first dot product. So I'm going to call this vector the cross product. I'm going to say it's C, because it's a cross product, right? So I'm going to say C dot, C dot U. It has to be 0, right? And eventually I'm going to calculate also C cross V. It has to be 0 to show that both of them are perpendicular. Okay, so the dot product, easily just multiply the x components, the y components, the z components, and add all of them together. So let's do that. So I have minus 2 times minus 11, because here, minus 2 times minus 11, that's 22. Okay, 1 times minus 1, that's minus 1, and 3 times minus 7 is minus 21. So if you see 22 minus 1 is 21, minus 21 is 0. So that means C is actually perpendicular to U. That's the first statement. The second one, and also made the same mistake, it's not cross, it's dot. Okay, don't do that mistake. So you multiply again, 1 times minus 11 here, that's minus 11, 3 times minus 1, minus 3, minus 2 times minus 7 is plus 14, and as you can see, minus 11 minus 3 is minus 14, plus 14 gives me 0, and I can tell that C is also perpendicular to V. That concludes that the new vector C is orthogonal to U cross V, and it's orthogonal to both of them at the same time. So I hope you learned something about the cross product today. If you have any questions, don't feel free to leave any comments, and I'm going to get back to you as soon as I see them. Good luck.